Hi, in this video we are going to see about the peak compensation. What is a controller and what is its use? Controllers are a fundamental part of control engineering and used in all complex control systems. It is a mechanism that seeks to minimize the difference between the actual value of a system and the desired value of the system. The important uses of the controllers include: controllers can improve the steady state accuracy by decreasing the steady state error. As the steady state accuracy improves, the stability also improves. Controllers can reduce the unwanted offsets produced by the system. It controls the maximum overshoot of the system. It helps in reducing the noise signals produced by the system. And also it helps to speed up the slow response of an overdamped system. The types of controllers: first one is continuous controller and the second one is discontinuous controller. Continuous controller, controlled variable, also known as the manipulate variable, can have any value within the controller's output range. Continuous controller has three basic modes. The first one is proportional controller, second one is integral controller, third one is derivative controllers. In discontinuous controller, the discontinuous controllers manipulate the variable changes between discrete values. Depending on how many different states the manipulated variable can assume, a distinction is made between 2-position, 3-position and multiple position controllers. It operates on very simple switching final controlling elements. The combination of these modes to control our system such that the process variable is equal to the set point. These three types of controllers can be combined into new controllers. The first one is proportional and integral controller, that is PI controller. Second one is PD controller, proportional and derivative controller. Third one is PID controller, proportional integral derivative controller. For a proportional controller, there are two conditions and these are written below. The deviation should not be large, that is, there should not be a large deviation between the input and output. The deviation should not be sudden. The output is directly proportional to the error signal. As we know, in proportional controller, output is directly proportional to the error signal. Writing this mathematically, we have A of t is equal to Kp into E of t, where Kp should be kept greater than unity. If the values Kp is greater than unity, then it will be amplified the error signal, and thus the amplified error signal can be detected easily. The advantages and disadvantages of proportional controller. The advantages is reducing the steady state error, thus makes the system more stable. The slow response of the overdamped system can be made faster with the help of these controllers. The disadvantage is due to the presence of these controllers, we get some offset in the system. Proportional controller also increases the maximum overshoot of the system. Activity: integral controllers. The output is directionally proportional to the integral of the error signal. To analyze integral control mathematically, an integral controller output is directly proportional to the integration of the error signal. Writing this mathematically, we have A of t equal to Ki into integral of 0 to t e of t dt, where Ki is an integral constant. The integral controller is also known as reset controller. The advantages of integral controller. Due to their unique ability, integral controller can return the controlled variable back to the exact set point following a disturbance. That's why these are known as reset controllers. The disadvantage is it tends to make the system unstable because it responds slowly towards the produced error. Derivative controllers. We never use derivative controllers alone. It should be used in combination with other modes of controller because of its few disadvantages which are written below. It never improves the steady state error. It produces saturation effects and also amplifies the noise signal produced in the system. The output is directly proportional to the derivative of the error signal. The derivative controller is mathematically written as a of t equal to kd into d e of t divided by dt. Thank you.